Okay, so welcome to the third session of the OpenMusic Study Group. We're going to be looking just at sort of pitch material and the generation of sort of pitch structures, just focusing in on that. I'm going to share my screen. So I had a few, just sort of fired a couple of things together. First of all, it might be just an idea to anyone who's maybe new to OpenMusic, just to kind of quickly give an overview of kind of how OpenMusic deals with kind of pitch material. If anyone wants to jump in or say anything about or correct me on anything, feel free to do so. But OpenMusic will use MIDI sense to read pitch material. The main ways, the main kind of components that can read MIDI sense are the note object, got chord and chord sequence. I think it's always the second inlet will read the MIDI sense data. MIDI sense are more or less MIDI notes, but with an extra kind of 2 digits on the end. So 60 is obviously middle C in MIDI notes, but because we have sort of multiplied this by 100 to get MIDI sense, it allows for us to look at real kind of microtonal notes. So if we get sort of 50, we can see, we'll have to change, if we go in to our voice object, we can change it to quarter notes. We can see it's changed. The other ways OpenMusic can take pitch information are obviously frequency. So we've got the MIDI sent to frequency. So if we take A4 is, well, in fact, we'll put in the note. So we go in and we put it up to A. We should, if I bring up my OM listener, get 440. So we can do MIDI sense. I don't know if anyone else has used the note to MIDI sent. I was sort of looking at it. It seems to not be quite right. Because I always thought sort of C4 should be 600, but it seems to be out by an octave. I don't know.
And just to say, it doesn't use the American standard pitch notation. It uses a variant, so everything's sort of offset by
right. I was wondering.
Yeah.
Okay, so what's it using then? Actually,
I'm not sure if it's using its own thing or if it's using something derived from the MIDI standard, but
right.
I mean, it is internally consistent. It's just everyone assumes it's going to be the American system, and it's not.
Okay. Yeah, well, that was my assumption as well. I always think C4 is middle C, and I just was I've never really used it, but I thought I'd better kind of look at it if I was going to do just a quick overview. And then obviously kind of was surprised by it not kind of following what I thought it was going to do. So we know that the OpenMusic will take MIDI sent information, and then I mean, one of the ways that I've always kind of built up sort of scales and things is the arithm sir, to more or less build a string of notes. Obviously, it will, you can either plug in the MIDI set number or a note object. If we change this to 100, it'll obviously no longer be microtonal. And then if we even go 25, we'll get even more. So yes, another way of doing that is to sort of add. So if the way we talked about sort of absolute values, if you generate a list of absolute values and then add them to a note, that will also give you a scale. So it's one of the really interesting things about OpenMusic, I think, is there's always sort of 6 or 7 ways of doing the same thing. And, you know, that's, you can also use the dx to x, which more or less does the same thing as the adding the absolute values. One of the things that I think was sort of I can't remember who was it asked if they wanted to learn about Sdif, things like that. I can't remember. But the way I've just kind of fired. I haven't worked a lot with this myself, so if anyone sort of sees anything wrong, please feel free to jump in, and we'll tweak the code as we go. I can't move some of those without setting my stop share. So I thought what I'd do is I'd just fire up a quick building a Sdif from scratch. So if we take, so just to quickly kind of just get in some audio right away, I'm going to just use Audacity. Obviously, because I'm going to be using the human voice, there's going to be a lot of different overtones and things, so it might, it'll be quite messy. As opposed to if we were using you know, an instrument playing a pitch, will obviously just give you the fundamental and some overtones. Obviously more complex sounds are going to create a lot more different partials. So we'll see how messy this can get. So we'll see if this will work. So this is a test. So just nice and easy. This is a test. So we just take out the bits that we want. This is a test. Just see if I can just save I'll just save the file. So we want it as wave because we're obviously going to be, I'm going to be putting it into Sphere. So OM study 3. So if I open up where's my Sphere? There it is. So now we can go in, find my file, and we can see, sorry, This is a test. So we've now done an analysis of just the quick recording that I did. If we were to save that now, and just load that into OM as is, we'll see how messy it is. So I need to get this out of the way without clicking my stop share. So what I've done is I've just got my going to load in the file we just made. I'll lock that. So now we should get an absolute mess of chords. Yeah, sounds interesting. So we put that sort of into our voice object to sort of see what that looks like. I mean, it's kind of just a mess. I don't even think it wants to deal with that. Yeah, it's getting very glitchy. So that's obviously working out one of the sort of a way of kind of cleaning up this is to go into edit, and we can sort of I more or less just kind of fiddle about and sort of see obviously below 0.3 seconds, really just go in and kind of with no rhyme or reason just kind of clean up. This is a test. So you can see our audio gets slightly less complicated. So we then save this file. So we've cleaned it up, kind of removed a lot of the other partials. And let's load that in, and hopefully it'll not look quite as messy. It looks a bit better. So you can see we've lost a lot of that. A lot of the higher frequencies that just kind of go mental on the very low frequencies, and then I fired this into a voice object and kind of adjusted the speed so it's hopefully similar to what was said. So that's us. We have our kind of this is a test and the analysis. It's pretty close. So I don't know, do you want me to sort of explain kind of what's happening in here to sort of see, or? Yeah, we'll give it a quick. So more or less it's going into this chord seek object, which I just pump straight into the first inlet. The way of this kind of voice object is just a little kind of sort of go between, so I can just pass the material into the chord seek, the voice object, so I can sort of re-plug it in once I've kind of messed about with the rhythms, because I find whenever you use just chord seek into a voice, it'll adjust it to be the length of the a single bar. So it's always a bit slower than the actual chord sequence. So we get it was just a little bit faster. So I'll not really go through the whole mess that I've made here, but it's more or less a little working out the actual adjustments of what speed the total duration of this is, because if we can see sort of 1,600 milliseconds. This is going to be 3,000 milliseconds. So we want to sort of adjust it accordingly to bring it down to 160 milliseconds, the same speed as the original input. And this is just kind of a little program I kind of threw together just to pull out the information that I need and to tweak it accordingly. And yeah, and then sort of plug it back into the tempo, so that we then have our adjusted speed. So that's kind of the way the Sdif. That was I haven't really used it too much, but I was kind of playing about with it, and that's what I came up with. A way of kind of just putting in some audio, and yeah, getting some analysis and just really outputting what was put in. The way of kind of, you know, generating sort of pitch material, you know, once this is in here, I've just tried to recreate kind of what was put in, but obviously, you know, we can see that, you know, these pitch material is going to just be there. So really whatever we want, you know, our chords are in lists, our single notes are in a list by themselves. We can really do whatever we want with that information once we've got it in. You know, we could use it as the basis for another rhythm. Doesn't need to, I kind of extrapolated the rhythm from the original chord sequence, but these could be really repurposed in any way, shape or form that we want. Don't know if we António, do you have any patches, pitch material that you've played with, that you have that you want to share, or? Oh, I think your audio is switched off, António.
Okay, sorry. Before that, I just wanted to grasp a step that I missed a little bit. That's when you generate through Spear the sound material because I never work with the Sdif, and so you must save the sound file you create in Spear in some format. You export it in which format you have exported?
That's the Sdif file. So so from Audacity, I save it as a WAV file.
Yes.
And then the WAV file. So if I just.
Sorry. Yes.
So if you open the WAV file in,
yes.
So if I get that was the.
Yes.
It'll analyze it.
Yeah.
And output it, and then from that we save the .sdif file,
okay.
And that's so from Spear will create our Sdif file, which we can then put into OM.
Okay, let me see. Okay, sorry. Oh yes. Okay, nice, nice. Because that step in changing from Windows, I have missed that one. Because
Sure.
normally to generate some material, I rather use the OM AutoSculpt in this way. So
Okay.
it's interested to me to see, because the cleaning up you have done with this material before this step for Spear. It's a nice way to clean something up and work a little bit with these ones.
Do you have a would you be able to share share your screen and show us what you would have done?
Yes. So sorry, where I've put it.
Because it'd be interesting to sort of see, your.
Yes, let me see, because I am here with. I've configured Zoom in a way that now it's quite a mess. Let me see. Maybe it's easier through the desktop, I think. Yeah. Otherwise, now. Sorry.
That's all right.
Now you see my desktop, I think. No? Yes. Okay. This is still under work, because I have many other workspaces, and I had a problem between, I think, OM 5 or from 4 to 5 or 6, and it was a mess. Many work I have to redo it. Normally, I would. These are just little patches, Sorry, I must see what is this? No, this. Well, normally, as you see, it's I work in a kind of messy way. I like that. So just to normally to import some material from an analysis from AutoSculpt, and then to inject it in this object. So I don't remember exactly what could be this. But it's like, as you show, sometimes the material is not very workable, in the sense that there are some material that comes also. So this is just a very simple way, just to show that I use this this object that allows also to make some filtering. But I think the way you showed it, it's rather interesting and better, because you can fine tune what you want and prior to send to OpenMusic, Yeah. So in that sense, that's why I was interested.
Could you go back to that patch and just sort of explain what the different inputs in the audio scope to OM, just what the the 40, yes. Just to kind of go over what those are and what's actually being.
Yes, I don't know if you see now. You see the patch. Is it so?
Yeah.
Okay. Well, normally, sorry, I'm just. I see my my little text to add to there. Okay. Well, the analysis from Sdif comes into this object. Yes.
Perfect. Yeah.
Okay. This first, as you have showed the other day, with the keyboard D, you can see the help. But what it means is that the 40, it's the minimum velocity. First, it tries to change into a kind of MIDI, more or less MIDI material, you know. So the 40 is the less minimum velocity you should have, and 100 the maximum. Then I think this delta, this is so this is for velocity. This is a delta, which it means, I think, a material. I mean, all partials that fall inside this time span of 5 milliseconds will be gathered in one chord. You know, yeah. Maybe I don't know if I can do. Sorry, maybe showing how it works. Sorry, on this. Well, now it seems a kind of messy. Yes, no, it's okay. So what I'm going to do is to try to synthesize different. Now, if I do a kind of one, for example, maybe it's do different. No. Oh, I think it's missing
the file. Yeah.
The file. I don't know if I have some. No, I should have a file. It lost connection because I've put some material and then I go away with it. But that's the main idea. Here you define the time span you want to gather in chords, and after that you have here the minimum and maximum pitch material you want to retain. You know. I mean, all pitch material above 127 will be wiped out, of course. But as a MIDI sensitive, you can go further, and all below 12. The C, I don't know which one, will be also ripped out, okay? And then you have also the kind of approximation. Here it's the approximation with mean tone. Yes, and here the maximum polyphony you will gather. So here I put a maximum 13 notes simultaneously. So that's how and then it generates the chord sec, which is rather okay. I don't know if I can, maybe let me see just if I can, I think this is an analysis, a chord sequence analysis from this kind of object. So I'm gonna lock it, I'm gonna put it, and let's see what is the result, okay. And just to make things a little bit, so it plays. Okay, just to show you around, okay, I will put 4 notes, and maybe if I put, I'm gonna exaggerate so that you can see everything between the interval 1.5 seconds, which is quite large, will be gathered into a chord, and we'll see if it works, as you see. So it has gathered things and limit to a maximum of I would say 4-note chords. So of course it changes it can maybe sometimes change drastically, but composition, it's about that, of course. So, so it's I think it's a very interesting object, and it works quite well with AudioSculpt, of course, because in AudioSculpt you can have different ways of. I'm going to interrupt. In AudioSculpt you have different ways to take out the materials. You can make an analysis as partials, which is more movemented, or you can do it as chord sequences. So you must mark and make some work on the audio file. But I find very interesting the working directly with the Sdif file as you have done. So nice.
Yeah, no, it's interesting that, I mean, the working with Spear seems to be, I mean, you seem to have more control over sort of the pitch material with the ON, because you can sort of organize, well, I don't want so many notes or whatever.
Yes.
I think the Spear's kind of a more general kind of bit broader brushstrokes to kind of on the sort of editing down what can be with the Sdif file. Okay. Yeah, I have to say I've never really used much of the Sdif files for generating pitch material. I mostly use kind of algorithms and things like that for generating pitch material. I'm going to share my screen and maybe talk about that now, because obviously the drawing from a sequence, one of the things I've got here is just kind of a random kind of sequence, a sort of 12-tone scale, and then obviously the various kind of you can create an entire kind of matrix out of through the various different 12-tone processes. So I just have this coming in, then sort of go through the P or the different series and the inversion, and obviously the retrograde, and combine them all together in this little make voices. I've just got a loop going where I turn all the chord sequences into voices, and then there we have, in a poly, all of our different the whole matrix really from that one. So that's it's a nice quick easy way to sort of try and use more kind of OpenMusic can also do functional harmony, but it's a much more complicated process. Obviously the algorithms to kind of that you need to build in order to make something even. So I kind of threw together. I was looking at Fox's Grandis Parnassum, and I just looked at a first species counterpoint, and I was like, well, can I do that in a way I'm quite sort of quick and easily? So this is what I came up with as a kind of like quick and easy way of kind of getting first species counterpoint. So I just got a scale, a G sharp major scale, in which I I took random notes from it, 8 random notes, and brought them down an octave, obviously to kind of make it an alto voice, using the kind of I think it's the 4 rules for first species counterpoint that he uses. I kind of extrapolated to what the scale degree was going to be, and then obviously I needed 8 of those, so I used my Lisp length to kind of pull sort of 8 intervals, then sort of building a kind of a loop to kind of, I need to try and remember what all these do. These could be more neatly done, but I think this is more or less my my kind of quick and easy way of getting rid of consecutive fifths and octaves, which is more to, you know, to sort of look to sort of look through what intervals I've got, and, you know, try and find anytime they're two of the same, and then sort of change them out for more acceptable changes, just using a two schwas to kind of just put in, I think, a thirds and sixths, bringing those all together, and then using this. There's a lot of loops going on in here, but it's more or less just iterating through lists to combine them all together in order to make a kind of a very kind of quick and easy first species counterpoint. Obviously, the more sort of complicated the type of harmony you want to build, you know, you can sort of see it takes quite a lot of tweaking and fiddling even just to get to first species counterpoint. But really, it's the options are endless with kind of where you can go with generating pitch structures.
Yes, it's it. Oh, that's interesting. I was just let me see. Yes. Oh yes, because I don't know very well the Lisp function object. In fact, I've always, through the years, some problems in Lisp. I must say that as I have learned how to code, you know, in some languages, but fifth generation languages like Lisp or Logo, I think, I don't remember exactly the names. Too much parentheses, it's quite paradigm. So with that object, you can write directly your Lisp function. Is it so?
Yeah, I mean,
Lisp, okay.
I'm still really kind of learning how to kind of code all these things, but we'll go into that, and Nigel, you can jump in if I make any errors. The way the way I think about it's the function kind of the way they've kind of color coded. The first set of parentheses is going to be our arguments, and the next we've got beep is going to then be our code that's going to be executed. So obviously in so if we don't need to put anything in there, so we could just have this return we could have this just return a string, so it doesn't even need. So if I evaluate that, we can see in the listener we just get the hello string that I've put in. If we wanted to then I don't know, add 10 to whatever number, well, our argument's going to be our x. So we're asking it to take x and then add it. Just so for anyone who doesn't know, in my OM listener, I've got the editor, which is kind of like a little repl. So in Lisp, we put the kind of in the what's called it's the S no, I can't remember the name. The name of the type of argument that's going to take. But your function goes in first. So if we want to add something, we need to. It's add whatever and 1 and 1. So we're gonna and it's the same. Multiply 5 and 2 gives us 10, etc. So when we're putting in our lambda function, we get put in our x. We could also call this n. So it doesn't really matter what we put there. It's still going to work, and we can see it's now changed. And we're going to put in a 6, 10, just to kind of prove it doesn't really matter. We can stick in x. They even in the example says arg1, arg2, because it helps keep track. But it really doesn't matter. As long as we keep them the same. If I put arg1 and x, it'll not be able to find that, and we see we get our error message. So as long as we keep as long as we tell the lambda function, you're going to accept the argument arg1, and then as long as we keep it here, it should keep it happy. So we've we can bring in sort of loops and sort of longer lines of code here, but I mean, a lot of these things can also just be done in OM. Very often what I'll do is maybe build a little function first, so it really is like, if I'm adding 10 just to keep it all the same, we can sort of see, I don't know, and then if I want to, well, let's make this 100. So if I wanted to make that, take in a number, so multiply by 100, and then maybe add that or then multiply that by add that to say sort of 600s or MIDI cent. We could, to sort of try and do the same thing in our Lisp function. Well, we'll just call this x, because we're going to be, well, we're getting two values. We call them x and y. So if we take our we're going to first of all multiply. X is going to be our 6, and we're going to multiply that by 100. And then after that, this is, I'm going to sort of be doing this as I go, but I'll explain as I go the kind of the format.
Yes.
So we can sort of see our, maybe bring that down. No, I'll keep it up. So our first set of parentheses are the arguments that we're going to get in. So call them X and Y. We can call them, you know, A and B, doesn't matter. As long as we keep them consistent, then in the next parentheses is going to be what's going to be executed. So we're going to add sort of thinking in the order in which sort of things are going to happen. We're going to add 600. So there's our Y. So our Y is going to be 600 to X, which is going to be our X and 100. So if we sort of build it up, sort of working backwards, what order is do things need to happen? We then can see our X was going to be is our first in our arguments. It was going to be the first thing, so it's going to come in there. Our 600 was going to be our Y, so that's going to go into the second inlet, and we get the exact same thing being output by both. But what we've done is we've just put this into now code. I mean, it really is kind of
yes.
There's a really great YouTube channel, or it's called it's an English programmer called Baggers, and he has a channel called he's got a sort of a playlist called Little Bits of Lisp. I'll link to it whenever I put this up on YouTube, because he does kind of small deep dives on a function. So, you know, in this one I'm using this type of for loop, and he will go through, this is what's going to happen if we change this, you know, we're doing it by whatever.
This is actually something I wanted to ask. Hi, by the way.
Hi, yeah.
I've dropped in, and I've been there the first time, like 2 weeks ago. And actually, I'm already using for many years OpenMusic, but it's precisely because of this kind of more advanced problems that I was interested.
Yeah.
And so this is actually a very interesting tip. About, because I'm actually looking for like more advanced Lisp stuff, mainly because I don't know if you guys have read the book by Rosalie Hers on the stuff of Tristan Murail. Yeah, you probably have it there. Yeah. So what I kind of noticed is that like the really cool stuff, the way that Murail creates these typical sonorities comes from quite a deep understanding of lambda behavior in OpenMusic and like rather advanced programming concepts, and that's why I get a little bit stuck. I don't have a IRCAM assistant with a PhD in mathematics next to me. So no, great. Can you repeat the name, Alan?
The YouTuber name is Baggers, Baggers, but I'm gonna, whenever I put this up on YouTube, you can actually link other YouTube playlists. So what I'm gonna do is I'll link to that directly from the on this, so cool. So you'll definitely find it. But yeah, I mean, that's definitely, I definitely want to go into a lot more of that for this. I just wanted to, obviously for the first couple of ones, to go straight in. Obviously. To give some people who are new to OpenMusic sort of a fighting chance with kind of.
So I just wanted to say, like, if I disappear, then it's probably because it's stuff that I already know. But I think it's a really cool idea to set this up, and I'll be trying to take part as much as I can.
great.
But I think it's a wonderful software.
Great. No, I mean, I mean, I sort of like to use the kind of the basic stuff to kind of start and give, you know, so people can just maybe build a patch along. But it's still a study group. So if there's something you absolutely want to like
I'll
go deeper into, like we can absolutely do that. We can just pick, you know, because it's certainly, I mean, I know, I think Matthias last time was saying about he you know, actually building a library in OM is, I think it's something obviously, you know, a lot of people kind of would like to do, build your own functions.
With their own functions, and I was looking into it, but my programming knowledge is like.
Yeah, it's actually, it's a lot. It's not as complicated as you think, but I think having a video that just goes step by step how to go through it and kind of maybe just explaining why this is done, why we're running this.
It brings back a little bit the traumas of math classes when I was in high school.
But in that sense, maybe I can show one or two patches I have shared also in GitHub, because it's one of the libraries. I think it was very interesting. It was the that one that I think it's from Murray himself, because much of the material. I think even in OpenMusic and some of the techniques, I think were not implemented by him. I don't remember the story, but I attended one of the first. I have the happy possibility to attend some of the first Académie d'été at IRCAM with Murray, Manori, Rissé himself. So. It was amazing because all that stuff was not still very stable, but it was amazing to see that how they were putting in some way and inspiring people to put all these techniques. And maybe, I don't know if I can show you one or two things. Please. Maybe you can find, I don't know, maybe interesting. Let me see. I'm going to share the screen. Okay. Maybe, well, maybe the desktop. Let me see what it's best. Maybe the desktop it's easier. I don't know. Well, maybe I think now you are looking. I think.
Yeah, we got it.
Yeah, we see your workspace.
My workspace, is it so?
Yep.
Yes, there are one or two patches I have put in, but I think you were not still in the conversation in GitHub. And this is rather simple, but I think it was very. Sometimes I use it because it's the idea of making a transposition, but not, I would say, a note transposition, which could be rather simple. I mean, you just add something, but to transpose through harmonics, you know. This is, I think, this patch is published there. I mean, it's here you have app. You have a kind of a little sequence, you know. So if I put here just so that you can see the difference, I am going to put 71. I think you can see it now.
Yeah.
Yes. Okay. So if I make the computation, it changed here the first line where it says original list. It says now it's a B. It's a B and not a C. Okay. So this is just to generate this part here. It's just to generate a MIDI-sent list, okay? Then I want to transpose for add transposition of free. Free means I want to transpose to this material in the next free harmonics, you know? So that's why here it's quite approximate still. But if I transpose -7 harmonics, as you see, the transposition, the third line, it's not very, it's not a exact normal note transposition. Okay, why that? Because I am gathering here. First, I take a fundamental. I take the line, the original list. I deduce a fundamental. I see what harmonics it corresponds, and then I go through the harmonic number and not the note number. Okay. So this is how it works. I think you see the patch. This is the first list here that comes here. This is well, sorry. This is the harmonic transposition, and it's a loop. So I must see a bit, because I can provide a list of transpositions. I don't need to stay only with 1 or 2 transpositions, and I can say, please transpose this in many ways. And this is the core objects from the I don't remember. Sorry, from the library. I think you find it. This one. It's esquisse. Okay, I don't know if you see here yes, where you can find some in esquisse you can find some of Tristan Murray's techniques, doing modulations with I mean using sound synthesis or analysis techniques applied in the note domain. So, okay. So I don't know if it's more or less clear. Well, the code after, as you see, as you know, well, it's OpenMusic stuff. You must do very go in deep and deep and deep. But that's why. Well, I don't know if it was clear the idea of the code. So if I made, for example, a transposition of 1 harmonic up, 1 harmonic down, okay? So as you see, things are quite similar. But for example, if I transpose 10 harmonics upper, you'll see here in the second line, if it starts to, well, it's more or less the same draw, okay? But of course the harmonics are rather closed, so you will end to have just a line of repeated notes, okay? Yeah. So this was an idea of approaching a kind of world where you are more or less between notes and sound working, of course, in a kind of how I would say more or less spectral working. In the GitHub, you'll find that you have always more or less this harmonic transposition help all, well, where you can find, this is the main patch that makes the harmonic transposition, you know. But for because of safety reasons, I've put it gathered it all, and here you have the thing as it should work. I mean, you have the same thing, but as a patch, and here you have the patch, only the patch if you want to use it. Just you see. So yeah. This was one of them. Maybe the other, which I think it's interesting in that sense, it's what I call the Palimpsesto filtering. It's the same thing. It was published in one of the OM composers book, and it's the same logic. You'll see the patch, and what it makes, it takes two input patches. You can use MIDI patches or anything you want. And it makes a kind of super vocoder style. I mean, first, it can adjust the length of the files. These are two simple files just to show you what happens. Mm-hmm. You have a kind of file that is only this. Okay, this is just to see what's happening. And this is a little file to 4 chords, even if two of them are just one note, just to see what's happening. And what you will see here, it's the result. I mean, you'll see this scale approached in different ways. For example, this is a bandpass note. So the second note sequence will act as a filtering over the first one. So as you see, for example, you have only here a D in the second, so it only let pass the D when it finds the D. The other chord, the moment of the other chord, will only let pass notes if he finds a note in this sequence, the first sequence, that is through is the same. Mm-hmm. Then I start to become more or less crazy and to amuse myself. What if you make a rounding, not only exact notes, but on the pitch class, you know? I mean, if you have a D somewhere between this note duration, what's happening? So as you see, it tends to pass more Ds, you know. If he finds a D, it will let it pass. I don't know if it's clear. And then...
It is. It's kind of the...
So it's a kind of filtering, but with many methods, you know. For example, rounding for the nearest notes. So all notes will be in a sequence, will be around here in the first one, will be rounded to the note which is more approachable and rounded to the next pitch class. So this value in the app, it's just to adjust time changes. You know, you can have a sequence that they are not the same length in time, so you can let it be as it is, or to adjust, make a time stretch or time compound. So this was and it's the same logic again. You have here you didn't find the patch because this patch it's the main patch. So I don't know if find it interesting, but it's the idea of using note filtering things in the audio domain to the note domain.
No, that's really interesting.
Yeah, I have always the feeling a little bit, and then maybe we should continue with where we were. I didn't want to interrupt.
No, I mean...
No, if please.
But I have the feeling that for, like, you feel the origins in serial thinking a little bit. I really had a hard time, for example, implementing Diatonic transformations, or like just like simple doing an inversion of a chord with correct octave that moves up and stuff. That I find particularly difficult always to do, because it steps out of this idea that like in chromatic, in post-serial harmony, you always work with the absolute 12 pitches, and they are related to the MIDI numbers or to the pitch classes. But in diatonic harmony, you're in a relative system, you're in a positional system. And then suddenly OpenMusic really becomes kind of, you feel that it's not built to do that. But I think you can do really interesting stuff with it. And so it's mainly there that like I struggle to define a mathematical model. Like if I want to use some diatonic stuff or something, it should be, I can express it like this mathematically. And then once I can express it mathematically, usually it's not so difficult anymore to do, but it's this translation from like maybe a little bit more classical musical structures, functional harmony, diatonic stuff, which I think still you can use in a contemporary context. But it's really hard to do in OpenMusic, I find.
Yes, because I think you are not dealing with the notes themselves.
No,
you are dealing with the index, with the position
exactly.
of those notes. So you must make lists of lists with
indexes.
Yes, and you must manipulate both. It's a rather complex system.
This is the project that I'm doing right now. It's me a lot of pain. Anyway, I leave you guys to continue.
That could be the topic of a study group.
Yeah,
I mean, translating functional harmony and those sorts of processes and techniques into the open music space. I think that would be really interesting.
Yeah, I mean, I think it's definitely, I mean, we want to kind of keep this kind of, there's not a strict structure, you know, that's why we're just talking about pitch. So it falls under the umbrella of like what we want to talk about, but the definitely to sort of, I think as Nigel said there, like to deep dive into kind of looking at translating. I mean, I sort of showed briefly I think you, just before you arrived, I did kind of some first species counterpointy stuff to kind of show, and it's, you know, this is kind of working, translating the rules that you know that are kind of, you know, it was the Fox's first species counterpoint of, you know, the harmonies that he said, the consonances, you know, he goes are the, you know, these scale degrees, obviously, which are now indexed, obviously, in a way that OpenMusic can understand it, and then building in some logic with some if statements to kind of filter and play about with things. But it is, I think it definitely gets you know, in OpenMusic, you know, there's about 6 different ways of doing the same thing. Like I think the code is incredibly powerful, and you know, it's very achievable to sort of build these more functional harmonies, or, you know, in OpenMusic. But it's you know, the more complicated you get, the more complicated the code needs to be, type of thing. That's why, you know, just to get sort of first species, you know, we've got, you know, loops in everything, loops within loops, and just because I'm just constantly kind of looking at what I want it to do and sort of force, you know, but I think we should definitely look at that, because that'd be great to pick out just a couple of, you know, a functional, you know, some sort of functional harmonic progression that we want to build in OM, and how we do that. I think it'd be really interesting.
Yeah, there's time. I mean, these Lisp functions already it's very interesting to see.
Yeah, it's the Nigel actually put in our chat the YouTube channel with the guy. So if you, I mean, that will be really useful for really getting the most out of this Lisp function, because those are things that you can I mean, he's in those videos, he's using Emacs as his kind of editor. You can sort of, in a kind of hacky way, use the OM listener as the REPL that he's using. So you can use this to to kind of write functions, and so you can sort of see, you can use sort of Lisp pre-existing Lisp functions rather than I don't even know this work with the OM. So yeah, so OM is kind of the our whenever we open up an object in this, we're calling functions, and I mean I think it'll even work plus as well. It's trying to understand kind of what in what interface we're working with, obviously in the kind of the patches, sort of the, we're kind of, we have these objects that we're kind of connecting, and it really is this, you're doing the same stuff in the Lisp function or in this the OM listener editor. It's just presenting it in different ways that are obviously in I mean even within this I think you can even define functions as well. So if I call this hello, well, if we go into this, we can see if I type in hello, it's the function hello does not exist. Whereas if I give this the function hello, which will print hello, I misspelled hello. But so it's not hell. So we know, whereas I'll tell you, I'll fix that. I'll just add in my, because we saw hello
everything from basic Lisp should work, huh?
Yeah,
it has the Open Lisp engine.
Exactly. So now we're saying that now hello now exists where it didn't before, and because I give it no arguments, it'll just print hello, which is what I asked it to do.
At this point, is this local to the workspace, or I mean, if you save and you
no, once you kind of close stuff down, it'll yeah. That's why you would, you could use this to kind of experiment and and test out functions, and then once we have something, you can then pass it into the Lambda function. So we saw, whereas we needed define to kind of define a function, we just got using Lambda, so we can just give this 0 arguments, and you can see the next parentheses are the code that we want to execute. So we can literally just take this code, copy it, and delete our OM beep and paste it in, evaluate that, and it'll do what we were doing. And this, once it's in the Lisp function, then it's saved and you can close and open it, and the Lisp function will still be there. Just things that you define here in the listener aren't going to be remembered, but it's this is the code that you would use if I get my if I get the OM Tristan library, so I don't know, let's just pick just a function that they've got. If you
push E, then you can
see exactly. We're jumping straight into the code where you can see here's the obviously a lot more doing a lot more complicated stuff than printing hello, but the syntax is the same. We're defining the function and then our code, blah blah blah, and it's so once you've built this is the sort of, you could then translate this stuff into a Lisp file, into a library, and then give it a nice cool picture like that, whatever, I don't know what that picture is. Like a golden eye.
It's Tristan looking at us.
Yeah, that's silently judging. So I think we're kind of coming up to our kind of 1 hour and a half mark.
Then finish what you were doing. I'm sorry for interrupting.
No, it's there. The whole point is to go over stuff like this. I mean, we've kind of come across all our. We kind of covered everything. It was just to kind of go over pitch material. I mean, these functions obviously can be used to, do anything. From, it all depends just what the input is. So I'll just stop sharing that. I think we're more or less kind of, I don't really know if there's much else unless, sorry, you have to tell me how to pronounce your name? Joost?
Joost.
Joost.
Yeah.
Joost. Do you have any patches you want to kind of share?
I'll think about it for next time.
But if you're, yeah.
Like I've done stuff like António. Wait, António? Yeah, António.
Yes.
Yes. like like a little bit more than basic. I'll maybe quickly show my workspace.
Okay.
Give you an idea.
Yeah, perfect.
I push share screen. Yes. I don't know if I booted it already. The thing is that the last half or year, I have been developing a lot of stuff that I used to do in OpenMusic in Bach and Cage in Max MSP.
Max MSP.
Because I don't know if you know this, I own the Contambre sample library, which is, I don't know, not many people seem to know it, but it's a library, it's a sample library for extended techniques.
Okay.
And it's written in Max MSP, so you can actually do full microtonal maquettes. And I'll show you my sort of Frankenstein OpenMusic replacement in a second. But it doesn't do really the same stuff. So I see myself mediating between the two softwares.
Yeah.
Like for example, this is this is a chamber opera I'm writing. And here I'm doing basic stuff, like this is a patch that just calculates the odd harmonics or the odd position harmonics of basic notes, and then takes every one of those odd harmonics to again calculate in a second order. So it just gives lists of notes, and it's I don't consider this advanced OpenMusic stuff because it's just basically like mathematics, like simple mathematics applied to notes and frequencies and stuff. So, but then this, for example, this I'm Dutch, I'm Belgian actually, so I'm sorry for you'll see a lot of Dutch words.
Right.
But for example, this one, Kleine Igel, is it's a very simple piece. Very simple piano piece for children, and I'm trying to build algorithmic variations or algorithmically inspired variations. So that means that I start from a very simple element, and I've written a kind of spelling is like appoggiatura, not appoggiatura, but like if you have the do, you have do, re, si, do, this kind of thing. Mm-hmm. And so it develops a very simple system, and it adds a little harmony, and then suddenly it makes it puts it in time, and you get a theme actually. So this was a first experiment to just get the original theme explained to OpenMusic. And now the idea is that I just limit myself to basically these three algorithmic methods to construct a whole set of variations. So with the idea that that the piece is kind of agnostic of the existence of tonal harmony and just uses a given algorithm as a basis to generate new material. And I already found out how to make this, for example, this upper line, how to make it in a kind of 12-tone structure and with using only these algorithms. So, but for example here, just making so I actually, I cried out for help in the forum. Mm-hmm. And I asked some guy like, how do you do Diatonic so so here you see stuff like this is a lambda function, I think, that he wrote, and then this is where I get like to the sort of, this is for me getting a little bit more complicated.
Yeah.
But I find this when I think out of software development, I find it a rather how to say, like not very elegant way of expressing. So what he actually does is just creating for the whole pitch space, creating a kind of diatonic grid, and then just mapping it onto. And I think it should be more efficient methods should be possible. I don't know. It seems a kind of complicated, not very efficient way of calculating, because it really doesn't use this idea of indices. But I don't. There I'm like on the max of my OpenMusic abilities at that point. So if we could dive into somewhere there for some next session, I would be very interested.
Yeah.
Yeah, and for the rest, I'm just doing like tiny stuff. I'll quickly show you the editor. And I have to say, like, if you're interested, I can share the patches, but I make it very much for me, and it's extremely alpha state. So it's it's a spaghetti patch.
I was going to say I mean, what I like to do is obviously, if you're happy to, I like to kind of just, I have like from the YouTube channel have the patch, like the couple of the patches that we talk about, so that anyone who kind of just wants to go in and click and play about with what, with the patches, kind of almost a really easy, a good way to learn. So if, I mean, are you on the Facebook group?
Yeah.
If I find you, and if you want to, anything that you are happy to send,
I'll try
have a think about it.
Find the stuff what is useful for everybody, and like this is kind of a anything of the maquettes in OpenMusic for me. So I can actually, this editor is just genius, because I can take like snippets. I've made a kind of system where I can import larger. This is a Mexican. This is a partial track of a Mexican bird. I already tracked it, and then I can I double click, for example. I can load it into keyboard. I can do all type of transformation. So that's why actually this I don't do anymore in OpenMusic, because I can do it in back. If I take it this kind of little bit, for example, I go to my snippets, I copy. You can do all type of transposition. You can stretch. like this in the pitch trace and stuff. It's a really phenomenal editor. So I actually use this to make a kind of mixed resource maquettes of my compositions. So this, for example, it's difficult to show you how it plays because I already archived this project, but I can show you how it sounds, this rendering. I don't know if you're going to hear this. None of you should be able to hear my sound.
Possibly it should be connected to the Zoom should be connected to your computer audio. So if you play, it should be.
I see. If you don't hear, please tell me. So where did I put it? Wait, I'm sorry. I need to get it out of my. Yeah, it's in my Facebook. So now I can show you. So this is like open, like let me quickly check. This is Contambre. It's going to take 2 seconds to open, but it's a pretty heavy patch.
Yeah. But
it receives floating point MIDI and like messages like glissando or crescendo or dynamics. So for example, if I just load one orchestra that I'm using at the moment, let's see, here is one. It will load the samples, and then I can show you, for example, like, so this is like my first voice, and then here you can choose the instruments, and then, for example, if I want to add, so you can actually add like bassoon and violin techniques through one another. So I make a new technique. I choose, for example, string section, the violins or the violin, and then there is this, oh wait, let me put it higher so you can see. There is like a incredible amount of, can you guys see this?
Yeah, I can see just all the list.
Yeah, it's crazy. Or I might take the cello. You have every possible imagining playing technique. Mm-hmm. Like it's huge. So let's say that I take, for example, I take a hand-tamped con legno battuto. I just, wait, maybe it doesn't sound so loud. I'll maybe take something which is a little louder. For example, Berto Pizzicato. Can you hear this?
Yes.
Yeah, voila. And so like this, I make maquettes of my compositions, and it more or less sounds, so this is the computer render that you will hear. So it's me singing and Contambre playing. It's a song. So the quality is actually rather nice. Mm-hmm. I mean, compared to Sibelius Playout, for example.
Yeah, it sounds like a real instrument.
Yeah, actually, that was the most nice compliment I got from the group that was going to do the premiere. They asked, mm-hmm. like, which musicians did you hire for the demo? And I was like, nah. But so, yeah, so OpenMusic kind of is used for basic structures. For example, this harmony is based on prime positions, prime number positions of the harmonic series. And the great thing about the stuff in Bach is that actually when I, for example, take my odd-p-chord matrix here, I can actually say export to Bach.
Yeah.
And then it will, so I say odd-p example, and I will go to here, I will go to my maquette, and I will make a new one for comptable, a new template, or I will, no, sorry, I'm sorry, I need to port like this, odd-px, and voila, I have the full microtonal. So actually I got in a sort of really weird new system of writing where I make the maquettes fully here, even with not really, because I can quantize if I want, but I prefer sometimes to just manually to think and to write on paper, like how would I express this for a musician, not with a Pernio nested 13 tuplet in a tuplet, but like just try to write naturally, like make acceleran or make something like this. And so this is actually why for OpenMusic I'm mostly interested in creating structure, in creating frameworks, in creating structures, because then I can, and exactly in creating libraries, because then I can use it actually to just fill in material that I get from somewhere else. Because the playback possibilities, like yesterday I was working on if I take this bird, actually I can also send it to just wait, let me move the screen, to just a sine tone synth. And I can actually choose, I can also link it to MaxMSP playout devices I make myself and stuff. So so the content of the notes is something it's something which comes afterwards, and therefore for example just like this, setting up a structure with odd positioned harmonics, this is something which is not very interesting to do in the Bach environment. I mean, you can do it, but it's much more cumbersome than to do it in OpenMusic. And so I guess, but I will think about patches that could be maybe a starting point for the discussion here. I'm already happy that you guys don't look at this as like, what is this guy doing?
No, of course. Okay.
The patches look, a lot neater than some of the ones that I've made. And
I show the pretty ones.
Yes.
Definitely libraries. It's something that I definitely want to go into. I'm actually sort of been planning it, because I've been, the thing about OpenMusic is, you can do the same thing in a number of ways, and that's equally true for how to implement libraries. You can write, there's 3 different ways you could write a chunk of code and it'll still do the same job, but it's obviously, some are more Lispy than others, and some just will get the job done. I think that's, what you were saying about when you ask someone to make you, sort of help you out, and you sort of felt that there was a more elegant solution. I think there's one of a great thing that I read sort of when I was sort of reading up about Lisp and sort of looking under the engine, was very often the mantra is make it fast, then make it fast. So you do something quick when you need to make something, do it quickly, get it working, and then go back and then make it efficient. Go back over things, and I think that's always quite a good mantra.
I just mentioned it because also I mean, when I was looking up articles and stuff, often it's a lot about just like one or two algorithms to create a structure, and then a lot about talking about the maquette, which frankly I still hate.
I've never.
I don't know if you have found your peace with it, Alan. But...
I'm actually, one of the things I was trying to think of, possibly looking at them in 2 weeks' time, because I thought we've done rhythm, we've done pitch, so let's look at structure, and sort of how just putting, it's OpenMusic is very much like playing with Lego. You make little boxes.
Exactly the same.
You make your little boxes, and then you build it up. So maquettes seem to be that's. To be honest, I've never really used them, but for this, I think it's just. I mean, I'm hoping if we have a discussion.
I see these beautiful maquettes that Murai makes. So
I know, yeah.
So there must be a way to do it.
Definitely. But I think certainly I'm gonna, when I sort of promote this and make the little poster and stuff, I'm gonna write sort of maquettes and structure, and hopefully we'll get some people who know more about maquettes than me to maybe show their beautiful maquettes, and hopefully we can together we can discover the glories of maquette.
Okay.
But, I think we definitely. I think we're coming up to the kind of the 2-hour mark nearly. So really, thank you guys. Nigel wrote to me to say he had to go, but thank you, Joost and António, for joining me and sharing your patches.
Thank you very much, also for this sharing, because I think it's quite dynamic. Yes, and I'm willing to see you guys in next 2 weeks. And thank you.
So see you probably in 2 weeks, I guess.
Definitely.
Yes. Ciao.
Okay. So ciao. So.